we are again. This is the next video in the series on logarithmic equations. We're going to solve logarithmic equations and inequalities today, but before we jump into it, I want to remind us that there were some restrictions on the base. We looked at this in the past. The base cannot be, or the base must be greater than 0, but the base cannot be equal to 1. Now in the last video I goofed up and said something else like the base is greater than 1 but equal to 1. It was totally wrong. Some of you probably caught it and wondered what I was talking about. Well, I lost my mind there for a minute, but here's the restrictions on the base. Now in addition to that, there are restrictions on the result. And the restrictions on the result are in some ways even more important because it tells us whether our answer is going to be acceptable or if it's going to be an extraneous solution. So let's take a look at a couple situations. So how about log base 6 of 0? Well, what happens here is if we rewrite this in exponential form, bring down the result, and that's equal to throw the base to the other side, to the exponent, you realize that there's nothing I can raise 6 to that will ever get me 0. It won't happen. I mean, you put a number in there that's positive, a negative, or a fraction. Whatever you put in here, even if you put 0 in here, 6 to the 0 power is still 1. So nothing will give us this. So this is not possible. There's a restriction where the result cannot be equal to 0. The other situation is log base 6 of a negative 2. Or a negative number, for example. Let's put a negative around that. Better put parentheses on that. Well, what do we got here? Drag down the result, and that's equal to 6 to the n power. Now, this is not going to be possible either. Maybe not obvious at first glance here, but if I put anything in here for n, well, let's see, 0 will make it equal to 1, which is positive. If I put a positive number in here, I'll get 6 to the first or whatever, and it's a positive number. Even if I put a fraction in here, let's say 6 to the 1/6 power, I end up, that is the square root of 6, which is also positive. So I'm never going to be able to get a result that is here. So the result here cannot also be negative. So in summary, the result has to be, let's just use result here. I'm just going to use the word. The result must be greater than 0. Can't be equal to it. Cannot be negative. It's got to be greater than 0. Hang on to all of those restrictions because they will make a difference in how we solve problems. All right. All right, we're going to solve log equations and inequalities. Note that solving equations and inequalities is generally going to be done the same as before. Sometimes inequalities throw a little loop at us, and we'll have to show you those when we get to it. Now, at this point, there are two types of log equations that you're going to solve. One, where there's a log, a single log on one side. A single log, a single on one side, a single log on one side of the sign, and it has to be a solo. For example, you'll see something like this: log base 4 of n equals 5/2. There's just one log here, no logs anywhere else. Well, what happens here? Well, to solve this, you just drag the result down as we've shown before, throw the base to the other side, and raise it to the exponent. Now we can use the calculator if we wanted to and take 4 to the 2.5 power. We get the right answer there, but let's do it with a pencil here. I smell that 4 can be written as 2 to the second, and if I raise that to the 5/2 power, I end up with powers of powers here. This is 2 to the 10/2, or 2 to the 5. Well, 2 to the 5th power is 32, so n must have been 32. All right, let's take a look at this next one here. You'll notice I've thrown an inequality sign in here, and that's going to cause some special concerns for us, but we'll get to that at the end. All right, drag down the result, put the sign in the same direction, throw the base to the other side, and apply the exponent. So x has to be less than 25. Well, if I look back up here and I put numbers in here that are less than 25, notice that this result cannot be 0 or negative. It has to be greater than 0. So the correct answer here is actually x has got to be greater than 0 plus the part that we solved. There's this combination of the two. X cannot be less than or equal to 0. It's got to be in this region here. So you can see where the restriction made a difference in our answer. So these equations where there's a log on one side are generally pretty much all done this way. They're pretty straightforward. Let's take a look at the other type. All right, let's take this problem here. The second type of problem you're going to see is when there's a log on each side. Take a look at this problem here. See, there's a single log and they have the same base on each side. If they had different bases, that we'll get to that later, much later in the chapter. But if they have the same log base, same base on each side, we got a fairly easy project to do. Now, doesn't it make sense that if both log bases are the same, then their results have to be equal as well? So we're going to immediately jump out of the exponent world and rewrite this as p squared minus 2 equals p. This is one of the laws of solving logs, is that if the log bases are equal, then you could just let the results be equal to each other. Now this is easy to solve. We're going to subtract p from both sides to set this equal to 0, and then we're going to factor this. Oh, we got to know how to factor, don't we? This is going to be negative 2 and a positive 1. So when we solve this, that's right, when we solve this, we end up with p is equal to 2 and p is equal to a negative 1. Well, now those numbers, if we stuck them back in up here, let's see if they make our results less than 0. Put a negative 1 in. In fact, if I stick it in here, I can see right away that if I put negative 1 over here, it makes this one less than 0. Well, that's no good, so this is going to have to be an extraneous solution. And I notice if I stuck it in over here, I'd get the same thing. It wouldn't work. Negative 1 squared is 1. 1 minus 2 is also 1. So it doesn't work here either. But if it doesn't work in either place, any place here, it's going to have to be excluded. So our only answer here is p is equal to 2. You can see that the restrictions on the result make a difference on our answer. You have to be sure to check your answers each time. If you get a negative result, you may end up going, oh, wait a minute, maybe it doesn't fit. You know what? You could even get a positive result. Again, you could even get a positive result, and when you stick it back in, it makes you could get a positive answer, and when you stick it back in for your result, it makes it negative. We could even try this 2 here. 2 squared is 4, 4 minus 2 is 2. So that's okay, and it's okay over here as well. But you must always check your answers, and you're checking to see if the result is going to be greater than 0. Question mark. Is it going to be greater than 0? Got to be greater than 0. By the way, I want you to notice that I had to put this entire result in parentheses so that people didn't think I was just taking the log base 5 of p squared. And then the minus 2 at the end was kind of tagged onto that function here. But this log base 5 is of the whole thing. So if you've got multiple things in here, you're going to have to put parentheses around them to make sure that we know exactly what we're taking the log of. All right, let's take a look at this one here. Once again, this is that second type where there's a single log on both sides. And once again, if the two log bases are the same, then the results would have to be equal. So I'm just going to jump right down out of the exponent world and make these equal to each other. Sometimes we will flip this sign around, but I'll talk about that later. I don't need to worry about it today. Let's solve this, subtracting x from both sides. Adding 4 to both sides. Dividing by 2. Now you can see that all of the normal steps that we've ever used in solving still apply. If I'd had to divide by a negative, I would have turned the sign around here. So all the same rules apply, but if there's a log on both sides, we simply set the two logs equal to one another. All right, so now you have enough information to do the second assignment here. That's assignment E. That's page 535. Problems 12 to 17. I added 17 in there. 33 to 59 all, but skipped 45 and 46. In the next video, we're going to talk about logarithmic scales and how to solve some word problems in logarithms. So, arrivederci. See you next time.